Hello there, welcome to the June 2019 paper 1. Here we're looking at question of 5. A tank at a chemical plant has capacity of 250 litres. The tank initially contains 100 litres of pure water. Salt water enters the tank at a rate of 3 litres every minute. Each litre of water entering the tank contains 1 gram of salt. It is assumed that the salt water mixes instantly with the contents of the tank upon entry. At the instant when the salt water begins to enter the tank, a valve is opened at the bottom of the tank and the solution in the tank flows out at a rate of 2 litres per minute. Given that there are S grams of salt in the tank after t minutes, show that the situation can be modelled by this differential equation here. So what we're going to start to do is we're going to start to build up parts of this formula here and link it into the description that we've seen from above, linking the words to the parts of the formula. So we're going to start by looking at the amount of salt entering the tank. So the salt entering the tank is going to equal 3 grams per minute. So 3 grams per minute. So that probably refers to the 3 at the start. Great start. Okay, good. Now we have to consider the amount of salt leaving the tank. So first of all, we need to start off by considering how much water we have in the tank, because what's going to happen is the salt is going to disperse into the water tank and then start leaving. So we need to consider first of all how much water we have in the tank at a certain point in time. So the amount of water first, the amount of water is going to be equal to 100. It starts at 100 and then every 3 minutes, so every minute 3 litres gets added and every minute 2 litres is subtracted. So that's going to give us in total 100 plus t litres of water in the tank. So every minute it gets 1 litre more of water. Right, so now once we've put a lot of salt in and once the water level starts to rise, we need to consider now how much salt 1 litre of water has. So if we disperse the salt straight away, then and we build up to a salt level S, then each litre of water has, if S is the salt level at that certain point in time, then it's going to be S divided by 100 plus T. That's the amount, each litre of water has this amount of salt in it. Okay, so if the total amount of salt is S at any point in time, then we have to divide it by how much water there is. So each litre of water has this amount of salt in it. So now if we have 2 litres leaving, then the amount of water that's going to be leaving, the amount of salt that's going to be leaving is, the 2 litres leaving means 2 lots of 100 plus T of salt is leaving. So, therefore, the rate of change of salt as time goes on is equal to 3, because we're adding 3 grams of salt every minute, minus taking away 2 litres of salt, so not 2 litres of salt, 2 litres of water every minute, and that is 2 lots of S over 100 plus T, which is equal to 3 minus 2S over 100 plus T. So there we are, that's the answer to part A. Let's now move on to part B. Okay, so hence find the number of grams of salt in the tank after 10 minutes. So we've got ds by dt equals 3 minus 2s over 100 plus t. Now I'm thinking here, can we combine the right-hand side and then separate the variables? I don't think we can. I think we need to use the first order differential equations technique here. So ds by dt, I'm going to move all of this onto the other side now. So it's going to be plus 2 over 100 plus t times s. So I've just rearranged this thing here. I've popped the s onto the side, will equal 3. And now it's a first order differential equation where we have to use an integrating factor to solve it. So the integrating factor is going to be e to the integral of 2 over 100 plus t dt, which is going to equal e to the 2 ln 100 plus t, which is equal to, now before we cancel out the e and the ln, we need to incorporate the squared into it, so it's going to be 100 plus t squared. Now we can cancel out the e and the ln, so it's going to be 100 plus t squared. So therefore our answer is going to be 100 plus t squared times s equals the integral of 3 times 100 plus t squared dt. And this integral on the right hand side isn't too tricky. You can either do it by integration by substitution, or you can just think of it as a polynomial integration, increase the power by 1 divided by the new power. So it's going to be 100 plus t cubed plus c. Now if there were whatever the differential of the inside the bracket was, we'd need to divide that to the front as well. Not if it's too complicated, but if it was a number we could divide it to the front as well. We don't need to do that here because it would be divided by 1. Let's now divide through by 100 plus t squared, and we're going to get 100 plus t plus c over 100 plus t squared. Let's now plug in. Now initially, remember that the water was fresh, so therefore when t equals 0, s equals 0. So it's going to equal 0 equals 100 plus 0 plus c over 100 squared. So therefore 100 squared, we move that onto the other side, we're going to get c minus c over 100 and then another 100, so 10,000 I think, equals 100. Oh Jesus, this is going to be a million now, so it's going to be minus c is going to equal a million, so c equals minus a million, so therefore s equals 100 plus t minus 1 million over 100 plus t squared. So hence find the number of grams of salt in the tank after 10 minutes. Okay, let's go ahead then. So s equals 100 plus 10 minus 1 million divided by 110 squared, which is going to equal, let's grab a calculator for that, and that's going to be 27.4 grams. Okay, so there we are. So that's the answer for part B, 27.4 grams. Let's move on to part C. So, when the concentration of salt in the tank reaches 0.9 grams per litre, the valve at the bottom of the tank must be closed. Part C is find to the nearest minute when the valve would need to be closed. So, what we have here is a concentration of 0.9. What a concentration means is the amount of salt divided by the amount of water in the tank. So if this is the amount of salt, then the concentration formula, concentration is going to be the amount of salt divided by the amount of water in the tank. So it's going to be 100 plus T minus 1 million over 100 plus T squared over the amount of water in the tank. Now remember, the amount of water in the tank was 100 plus T. So what I'm going to do here now, the concentration is going to be, I'm going to split it up into two fractions. This fraction here, and then this fraction here. So it's going to be 100 plus t over 100 plus t is 1 minus 1 million over 100 plus t cubed. And the concentration needs to equal 0.9. So what I'll do is I'll move a few things onto the other side, and I'll get 0.1 equals 1 million over 100 plus t cubed. So therefore, if I now divide that onto the other side and times by 10 onto the other side, I'm going to get 100 plus t cubed equals 10 million now. I don't think I've seen such a big useful number in a maths problem in ages. Now we need to cube root both sides, and if we cube root both sides, we're going to get 215.44. So 100 plus t equals 215.44. And then take away the 100, so therefore t is going to equal 115 minutes. So there we are, that's the answer to part C. So now the question is evaluate the model. So the only thing that's really to discuss here is the water going to start overfilling when it gets to 115 minutes? Now if you remember right back at the start of the question, it said the tank had a capacity of 250 litres. So if the amount of litres that is in the water is 100 plus t, is equal to 250, and if it starts to overflow, then t is going to have to be 150 when it starts to overflow, so therefore t has to be less than or equal to 150 in this model here. T can't go above 150 because otherwise it will start to overflow. So this is fine. The amount of concentration will be reached before the tank starts to overflow, so you might be able to write that as a final sentence for part D. So the concentration will reach 0.9 grams per litre before the tank reaches its capacity of before the tank reaches capacity of 250 litres, or by the time is less than or equal to 150. Wow, big question that one. 13 marks for question 5 there. Hopefully that explanation helped you out a little bit. And let's move on to question 6.